You should note that the method that we're going to use here is a table format, and we're doing this to basically get you used to using this table before we get into the more complex equilibrium type calculations. Okay, so we're going to kind of skip down to the problems here. Basically, we're looking at an equation now, and you should note that the equation gives us the particle ratios that are present. We have our reactants on the left-hand side of the equation. Those are the things we start with. Our products on the right-hand side. And if we're looking at this particular equation here, we see that it says that if I combine 2 sodium atoms with 1 chlorine molecule, I get 2 formula units of sodium chloride. Well, in addition to particle ratios, the chemical equation also can be used for mole ratios. So I can also read this equation as if I combine 2 moles of sodium with 1 mole of chlorine, I get 2 moles of sodium chloride. And so that's kind of the way that we are going to use these mole ratios from the balanced equation. And so we're going to set up a table, and our table is going to have 3 rows. And the first row we're going to call before, as in before the reaction occurs. This would be how much we have of each of the components. And the change line, middle line, that is what happens during the reaction. And the change line is the one that's going to correlate to the balanced equation, to those mole ratios that are defined in the balanced equation. So we can always, if I find any one thing in the change line, then I can use those mole ratios from the balanced equation to get anything else in the change line. So our goal in filling out these tables is really to get one thing in that change line, because then I can complete the whole table. All right, and then the last line is the after line. And so we're going to kind of shorthand this to BCA as the shorthand name for our tables. Now, one of the things you should note is that in a BCA table, we're only going to be working in moles. All right, so every number I put into here is going to be moles. And so in this first one, I'm going to put those units in there. But after that, I will just be putting numbers in. But just remember that it always has to be in moles, because, again, our balanced equation gives us the ratio of moles of reactants to moles of products. And so for our change line to be able to work, we've got to be working in moles. Okay, so here I'm going to kind of use the equation at the top as a way to organize my values that they're giving me and what they're asking me for. So here it says I have 2.6 moles of the chlorine gas, and it wants to know how many moles of the sodium chloride will be produced. Okay, so this is nice because now it's like I don't have to look at all the words anymore. I can just focus in on completing my table. Now, the first thing in doing this table is we're going to put in our zeros. All right, that's just, it helps if you do this the same way every time. And one of the reasons for that is, especially in a test situation, if you struggle with test anxiety or sometimes getting stuck, a lot of times if you have an approach where you do exactly the same thing to start these types of problems, then it gives you something to do, and sometimes that can, just having something to do can kind of unfreeze your brain and get you started. And just the act of filling out this table can sometimes help you see what the solution to the problem is. All right, so looking at our zeros, one of the things we know is that before the reaction, before we've combined any of the reactants, we have no product. So the first zero I'm going to put in is on the before line, and that's for the product. Whether I have 1, 2, however many products I have, they're always going to start at 0 because it's before the reaction has even happened. All right, then we're going to have 2 types of these problems, and in this podcast we're only focusing on the first type. And the first type is where they're giving me only one value for a reactant or a product. Okay, in this case I have 2.6 moles of the chlorine. It's asking me for moles of sodium chloride, and it says I have an excess but I don't know how much of the sodium. Excess meaning I have as much as I need. And so on these problems, what we're going to assume is that after the reaction, that both of those are going to be 0. All right, and we're doing that because we're just making the assumption that they react exactly. Now, when we get to the next podcast, which is on limiting reactants, we'll see that that's where we're going to start moving away from that assumption, because in that case, they're going to be asking you questions like, well, how much is actually left over? But in these, we're mainly focusing on how much product can be produced or how much of the reactants did we start with. And so for these, where you only have one amount, it's helpful just to put 0 on both of my reactants here. And I'm just, again, I'm making the assumption that these are reacting exactly stoichiometrically, like in this case, the 2-to-1 ratio of the sodium to chlorine, that we're reacting exactly with it. Even though it says I have an excess of sodium, I'm just ignoring that because in this problem, it's not really important. Okay, so now we've got our zeros in. We're going to put in our given, which is the 2.6 moles. Now, once I have something in the before line and something in the after line, right, I know what my change is. It's going to be a minus 2.6. All right, I'm going from 2.6 at the beginning. I'm ending at 0. My change was minus 2.6. All right, and what you'll notice with these basic stoichiometry equations is that we are assuming it always goes in the forward direction, meaning our reactants, the change of the reactants is always going to be negative. The change in the products will always be positive. I'm always using up the reactants, and I'm always producing products, okay? And I'm going to, for this first example, I'm going to fill out all of the lines of our table. But really, it's only asking us about the sodium chloride. So in a real situation where you were doing this problem, you would not need to fill out the line with the sodium on it. Okay, so here, now, I'm looking here and it's at I want to know the change in the sodium chloride. Okay, well that's where, again, I'm going back up to the ratio that's defined by the balanced equation. And even though this is a real simple ratio, I'm going to go ahead and just write it out so that you can see where it's coming from. But in this one, the math is nice and easy. It's a 1-to-2 ratio. 1 mole of chlorine produces 2 moles of sodium chloride. So if the change in my chlorine is 2.6, then the change in the sodium chloride is going to be 2 times that. Okay? And again, what you would do is, as long as you have a balanced equation, you're going to have the left side of this ratio that I'm setting up. Okay? So the balanced equation gives me the ratio that 1 mole of chlorine will give me 2 moles of sodium chloride. All right, and I don't have 1 mole, I have 2.6 moles is my change in the chlorine, and then I'm solving for the moles of NaCl. And so as you can see, if I solve for my unknown in that ratio, the answer is going to be 5.2 moles, all right, and that value that comes out of this ratio is what's going to go in the change line. All right, and so then my after line would be 5.2 moles, and that is the answer to the question, is how many moles of sodium chloride could I produce from 2.6 moles of chlorine. All right, now if we had a question about the sodium, like if it said, well, how much sodium would you need to react with the 2.6 moles of chlorine? Okay, we could again fill in the change line. Because again, once I have anything in that change line, I can use the balanced equation to tell me what the ratio between that and one other thing should be. So in this case, my balanced equation tells me I have a 1-to-2 ratio between chlorine and sodium. So I should be using twice as much sodium as I am chlorine. So if my change in the chlorine is 2.6 moles, the change in the sodium is going to be 5.2. All right. The other thing to notice is that anytime you have components in this equation that have the same coefficients, the change, the magnitude of the change, should be the same.